Hi guys, welcome back. So I'm going to go through some Gaussian elimination with you, and I want to go through a tech-free example, and then I want to go through a tech-active example. I'm not the most literate person when it comes to using the calculator, so I'll do my best, but I'll go through this tech-free version first. So just as a quick review about what the goal of Gaussian elimination is, the whole idea of Gaussian elimination is we have some sort of system of equations, and what we do is we take the coefficients of each of these variables, so the coefficient here 5 and the coefficient here -2, and then the coefficient 3 and 4, and we pop that into our coefficient matrix. These solutions, or these answers that we get at the end, these is called our value matrix. So when we're trying to solve systems using Gaussian elimination, we're going to put this into some sort of augmented matrix. And the whole goal of this is to get this into one of two forms. The first form, this is called the reduced row echelon form. So the reduced row echelon form is basically where we manipulate this little scenario here until we get the identity matrix. So this again is just called the reduced row echelon form. The other way that we could do this is rather than reducing it all the way down, we might get something like, let's say we have 1, 2, 0 and 1. So we don't quite have the reduced row echelon form here, but we have our diagonal of 1s, and this lower triangle will only contain 0s. So once we have this lower triangle that's only got 0s and our diagonal of 1s, this is just called the echelon form. So either way, it doesn't really matter. Excuse me. Either way, it doesn't really matter which form that you get it into, just that it needs to be in one of these two forms. Okay, so let's try doing this first example. So we've got our augmented matrix, 5, -2, 3, 4, and then our values 8 and 10. Now, the first thing that I'm going to do is, let's just go through our 3 different elementary row operations. So the first thing that we can do is we can swap any row. The second thing we can do is we can multiply any row by a constant. So in other words, we're finding the scalar multiple of that particular row. And the third thing that we can do is we can add any row into another row. So the first thing I'm going to do is to multiply this whole row by 2. So this is going to give me 10, -4, and 16. And I haven't changed this row at all. So this is just going to be 3, 4, and 10. Now, what I can do is I can get this top value of 0 here by adding these 2 rows together. So when I add these 2 rows together, I'm choosing to replace into one of those rows. So I'm going to replace into the top row. It doesn't really matter which row you replace it in, remember, because you can always just swap it around afterwards. So if I add these 2 together and I replace into this top row is now going to be 13, 4 and -4 makes 0, and 10 and 16 makes 26. And I haven't actually done any manipulation to this bottom row, so this bottom row is going to stay the same as what it was. So now you can see that this here, these are all multiples of 13. So I can times this by its reciprocal, and then that's going to give me 1, 0, 2, and then again, this bottom row hasn't actually changed. All right, so now what we can do, now that we've got this in this pretty basic form, this is going to be a lot easier to manipulate because the goal here, I'm trying to get a 0 in this spot and I'm trying to get a 1 in this spot. So what I'm going to do, I'm going to multiply this row by -3, and then I'm going to add this row into this row. Now, I'm not actually going to write that information out. So all I'm going to do is I'm just going to show you the finished product. So this is going to stay as 1 and 0. I'm not moving them or manipulating them in any way. But if I multiply this by -3 and then add it here, that's going to give me 0. If I multiply this by -3 and then I add it into this row, that's just going to give me 4. And if I multiply this by -3, -6 plus 10 is going to give me 4. All right, so the last thing that we can do is I'm going to multiply this last row by the reciprocal value here of 1/4, so I can get a 1 here. And then that's going to give me the reduced row echelon form. So now this correlates to my first variable x, so let's write that as x, and then this corresponds to my second variable y. So the solution for this particular system of equations is x is equal to 2, because that's my value, and then y is equal to 1. So because this is a pretty algebraic process, there's lots of different ways that you can go about doing this method. So I'm not really fussed. Just have a play around. I think Nguyen was the one who said it's like the world's crappiest sudoku game, and that's basically what it is. You just have to keep manipulating the variables until you can get what you want. All right, so now I might try and do a little bit more of a complex example. Okay, so we've got a second example here. So the first thing that I'm going to do is I'm going to write down the augmented matrix. So to do that, I'm going to take each of these coefficients. So I'm going to have my columns for X, Y, and for Z. So the first one is going to be 5, 2, -2, and then the value will be 2. Then the next one is going to be 2, 5, and 3, and our value is going to be -8. And then lastly, we've got 1, 3, and -4, and our value is going to be -11. Okay, so this one's a little bit more complicated because we're dealing with a 3 by 3 matrix now. So typically this is where I would grab out my graphics calculator, but you might not have that option. So let's go through and let's see if we can solve this by hand, and then back substitute to double check that those solutions are actually correct. So the first thing I'm going to do is I'm going to try and find a value that's going to be pretty easy to add into another row to eliminate it. So this one here, I can see if I was to double this and then add it into here, then I could probably get rid of that. So let's multiply this row here by -2, and that's going to give me 5 to, oops, sorry, -10, let's try that again, -10, -4, +4, and then -4 as my value matrix. And then these other rows, I haven't actually messed with them yet, so they're going to stay the same. 1, 3, -4, and -11. All right, now that I've done that, I can see that I'll be able to add this into this equation here. Excuse me, Mr. Doon. Sorry, guys. All right, so let's go through. -10, -4, 4. Mr. Doon just walking in on us, being all rude. No, anyway, sorry, let's continue. So adding in, so we've got, this one hasn't changed either because we're going to manipulate that third row. All right, so we're going to add this row into this row and replace row 3. So -10 and 1 makes -9, -4 and 3 is going to make -1, and then 4 and -4 is going to make 0. -4 and 11 is going to make -15. Okay, so let's continue. Let's see what else we could manipulate here. Now, I'm just having a look at this second row here. I could probably multiply this second row by 5 and then add it in to that row there. So let's do that. So let's do multiply this row by 5 and then add it into that row. Okay, so I'm not going to actually change this second row. I'm actually going to leave this second row as what it is. Oh, and the other thing I'm going to do, which is real sneaky, is I'm going to multiply this by -1 to fix up these negatives. So I'll end up with 9, 1, 0, and 15. Okay, so what I'm actually going to do is I'm kind of going to do it in one big step. I'm going to multiply by 5, and then I'm going to add it in to that top row. So 2 times by 5 is 10. 10 and -10 make 0. 5 by 5 is 25. 25 and -4 makes 21. 3 by 5 is 15. 15 and 4 makes 19. And then we've got -8 times 5, which would be -40. -40 plus -4 is going to be -44. Okay, so next thing I'm going to do just quickly to fix this up is I'm probably just going to swap a couple of these rows around. Let me look at what else I could do, because I kind of like to do 2 steps in one. See, I think this is where it's going to start getting a little bit tricky now. So I'm going to just try a couple of things and I'll just come back. I think that the next thing that I want to do is I think I'm going to change this equation here, because these numbers are starting to get a little bit big. So what I might actually do is I might divide through by -21. And this is going to come with a kind of crazy sort of solution here, but we're just going to leave it in fractional form to keep it pretty simple for ourselves for now. So this is going to be 0 still. Sorry, divided by -21. This is going to be -1. This is going to be -19 over 21, and this is going to be 44 over 21. And we haven't changed anything with this last line of working here either. Okay, so the next thing that we could probably do now is I think that I could probably add row 2 into row 3. Which row do I want to replace though? I'm thinking because I've already got the 0 here, maybe I can replace into here. Let's have a look. This is sort of like you just got to keep manipulating it and playing with it. You know what? This is the smaller row. So this is the row that I'm probably going to want to keep. So let's keep this row. Let's times this by -1 at the same time. So we're ending up with 1, positive 19 over 21, and then negative 44 over 21. Okay, so let's now add this row into this. Okay, so 0 and 9 is going to make 9 still. 1 and -1 are going to make 0. And then this is going to make negative 19 over 21. And this is going to make 15 plus 44 over 21. And again, I'm not just going to do that calculation yet because I'm still manipulating things and still playing around with things until I can kind of get the value that I want. I'm starting to kind of see some zeros coming through here. So for this one, maybe what I can do, rather than getting to the reduced row echelon form, maybe I can just focus on making this lower triangle full of zeros and making this diagonal all 1. And then I can show you the back substitution method. Maybe that's what will be a good idea to do. Okay, so to get this as a 0, the thing that I'm going to have to do, I'm going to have to multiply this row by a -4.5, and then I'm going to have to add it into that third row and replace that third row. Now, again, I'm not actually going to manipulate this line. Okay, I'm just going to leave that line as it is. I'm going to have to kind of do this all mentally. So that second line is going to stay the same as well. 19 over 21 and negative 44 over 21. Okay, so negative 4.5 times 2 is 9. Negative 9. Negative 9 and 9 is going to make 0. Oh gosh, this is where we get a little bit crazy, isn't it? The more I'm mucking around with this, the messier I'm getting. So I don't know if I just want to go back quickly to a previous thing to see if I can maybe make it simpler. This is why we call it the crappiest version of Sudoku, right? Because there's a whole bunch of stuff that you can do and manipulate, and you can still end up with a really crappy result. So if we go back, maybe if we go back to the most simple version, what was the simplest one that we had? This version here. So maybe let's go back to the beginning. Maybe let's try this again. Hold on one sec. I'm going to clear this up. All right, I think I've got myself on a bit of a better path now. So the first thing that I've just done is I've swapped row 1 and row 3, which is not going to change anything. And then now I've got this 1 up in the top corner. So that's a good start because remember with this reduced row echelon form, we want to try and get, echelon form because it's not reduced all the way. We're going to try and get this diagonal of 1s here. So I decided that's probably going to be the best spot to have this first row in. Now, because I've got this 1 here, what I can actually do is I can now use this 1 to manipulate the rest of these equations. So what I did, the next step was this row times by -2, and I added it into that second row. But I didn't actually replace that first row. I think that's where I was sort of going wrong before because when you replace it, it obviously is going to make it a little bit more complicated than what it was. And I want to try and keep these numbers as small as I possibly can. So I don't actually want to change the values here. I just want to manipulate the values so that I can add them into this second row. So I did -2 lots of this row, added into this row, and so that's given me this result here. So now what I'm going to do, I'm going to do the same thing, and I'm not going to manipulate this row because the numbers are pretty small. I'm going to try and keep these numbers small, but what I'm going to do is I'm going to multiply it by 5, add it into this third row, and then I'm going to replace that third row. So I'll show you what I mean. So this row is going to stay the same, 1, 3, -4, and -11. And this row is going to stay the same, 0, -1, 11, and 14. Okay, so now let's do this. So -5 times by 1, add it into 5, is going to make 0. So we're starting to see these lower triangle is starting to become all zeros now, which is what we want for the echelon form. Okay, so now let's do the same thing. So -5 times by 3 is going to be -15. -15 plus 2 is going to make -13. -4 times -5 is 20. 20 minus 2 is going to be 18. Negative 11 times negative 5 is 55. 55 and 2 is going to make 57. Okay, so we're starting to get somewhere now. So what might be a good move next? I reckon let's just do times this row by negative 1, because then we'll have a 1 here, won't we? So we'll just pop that over on this side. So that's now going to be 1, 0, 0, 3, positive 1, and that's going to stay the same. Negative 4, negative 11, 18, that's going to stay the same. Negative 11, negative 14, and 57. So we're slowly getting there now. Okay, the last thing we want to do, so again, I just want to try and make this lower triangle all zeros. So now what we can do, because we've got this 1 here, if I multiply this by 13 and I replace into here. So we're going to do row 2 times by negative 13. We're not actually going to change this row though. We're just going to manipulate that so that we can add it into that third row. So once we've done that manipulation, we're going to add that into row 3 and replace row 3. So we end up with 1, 3, negative 4, and negative 11. Again, this row, we're not actually going to change it. We're just going to use it to manipulate that equation. All right, so now if we did, we don't need to multiply that by negative 13. So 1 by 13 is going to be 13. Add that into that row, and I'm going to end up with 0. So good sign. Okay, so negative 11 times by 13 is going to be negative 123. So negative 123 plus 18 is going to be negative 105. Okay, so that's going to be our solution for this bit here, isn't it? Negative 105. All right, same thing now. So negative 14 times by 13. So I'm just going to do this on my calculator. So 13 times by, times by, what was the value? 14. So negative 182. And then negative 182 plus negative 14 is going to give me negative 196. Okay, so we're slowly starting to get somewhere now. The last thing that I can do to make this a 1 is I can just divide this whole thing through by negative 105. So that's going to give me 1, 3, negative 4, 0, 1, negative 11, 0, 0, 1. And then my value matrix is going to be negative 11, negative 14, and then 196 over 105. So again, I'm just going to leave that in fractional form for the moment. All right, so now that we've got this echelon form, so it's not the reduced row echelon form. I just can't write x is equal to this, y is equal to that, and z is equal to that. So what I actually have to do is use back substitution. So for this one here, the reason that this works, right, so this is my x column, this was my y column, and this was my z column. Now I've got 0x and 0y and 1z is going to make this value here. So I can just write that z is equal to this number here, right? Now if I go back to this second equation, I've got 0 lots of x plus 1 lot of y minus 11 lots of z, and that's going to be equal to negative 14. Now, since we know the value for z here, we can substitute in, and then we can rearrange to find y. So I'm just going to do that now off screen. Right, substitute in the value here, and I've worked out that the value for y is going to be negative 34.53 recurring. All right, last one. So now we're going to work out x. So this is the same as saying 1 lot of x plus 3 lots of y minus 4 lots of z is going to be equal to negative 11. So again, just using back substitution, I'm going to take my information for z and I'm going to substitute it in. I'm going to take my information for y and substitute it in, and that's going to help me find this value of x. So again, I'll just do that off screen. Okay, so assuming I've done this all correctly, I've just gone in, we knew what z was, we knew what y was, and we've substituted that in to find what x is. So now what you should do is you should go back in and substitute that in. I'm going to stop the video here. I might do the digital or the calculator active one in the next example. So this does get a little bit crazy. So if you were to get a question like this on an exam, you would probably get one that would be in the tech active exam, would be my presumption, or you would get a simple, like a 2x2 matrix, or maybe even a 3x3 matrix at the most in a tech free exam. So I don't think this would ever sort of go beyond that. I don't think you can really do a complex unfamiliar question of this particular type. All right, guys, I'll see you in the next video to have a go at doing the deck active one. Wish me luck. See you.